In the previous video, we took the data set that was passed to R from Power BI, added additional columns to that data set that are required by the visual that we're creating. And in addition to that, we created some variables that will be used to create some of the dynamic portions of our visual. Some of those include the title, the subtitle, and also the caption, as well as the annotation. Now that we have everything in place that we need to build the visual, what we will do now is use the GGplot2 package to build the visual that we see in the lower right hand corner of the screen. GGplot2 is based off of what is called the layered grammar of graphics. And basically the layered grammar of graphics is Hadley Wilkins' take on the grammar of graphics that was developed by Leland Wilkinson. If you want to find out more about the grammar of graphics, you can go to the link that you see, or the URL that you see in line 73. So let's go over the actual code. When you're building a visual and our visual using the grammar of graphics, the first thing you need to do is initialize a GGplot2 object. And you do that with the GGplot2 function. Now, when you initialize the GGplot2 function, you have the option of setting global arguments. And in this situation, you'll see that we are setting two global arguments. One is the data argument, and the second one is a mapping argument. Now, it's not explicitly written here, but we can type it so you'll know exactly what this argument is. And here you see the AES, or the aesthetic function, is used for our mapping argument. So by setting global arguments, you are telling GGplot2 that you want these attributes to be available, or these properties to be available to all subsequent layers of your visual. So our visual, all layers of our visual, and you understand more of what I'm talking about the further along we go in the video, all layers of our visual will have access to our plot data frame, and also will have access to the aesthetics that we define in our aesthetic function. Let's execute this code and see what the results of this code is. If we go over to our console and type P, you'll see that basically all we have is a blank chart. So let's go over this, what we did in a little bit more detail. On line 76, it's pretty obvious. We're using a data argument to define the data frame that we want to use for our plot. The next argument, which is probably not as intuitive to a person that's new to ggplot, is we're using the mapping argument to set the mappings that we will use in our visual, and we're using the aesthetic function, or the AES function, to do so. The aesthetic function allows us to map variables or columns of data in our data set to actual aesthetics in our visual. So let's print out our data frame in the console so that we can have something to reference while I describe what's going on here. So I'll type plot data in the console, print that out so we can see what we have. So you'll notice that in our aesthetics function, the x-axis is we are mapping the country field, which is this field right here that contains Belize, Benin, so on and so forth. We're mapping this field to our x-axis. And we're mapping our total expenditure percent field, this column right here, or this variable that you see in this position, to our y-axis. And then you'll see that our call out field, which is the field on the far right, we're mapping that to our field argument. Now, when you think of field in this particular situation, think of that as color. A lot of times the fill argument and the color argument are misunderstood to people that are new to ggplot2. You can think of the fill argument as the argument that you will use to color the inside of the bar chart that we're creating. If you use the color argument, all the color argument would do is color the border of that of your bars, but we want the whole bar to be colored a particular color, and we do that with the fill argument. And then the next argument that we define in our aesthetic mapping is the label. The label will show the actual value of each individual bar in our bar chart. You'll see that later on in the visual, and we use the information in the total expenditure percent variable or column as our source for our labels. So the next thing we want to do is, using this information, we want to create a column chart or a bar chart. And we do that using a geom underscore code, which is short for column, geom. And you can think of a geom as the geometric object that you're plotting on your visual. In this particular situation, since we're plotting a column chart or a bar chart, we're using the geom underscore column geom. Now, you would notice when you look at the available geoms that you have to use that there is one called the geom underscore bar. That has some properties that makes it a little bit harder to work with and less intuitive. So that is why we are using the geom underscore column. Once you start learning more about ggplot2, you will learn the differences and advantages of using the geom underscore code versus the geom underscore bar, depending on what your situation is. So let's execute this code to see what the output looks like. Execute that using Control R, then Control 2 to get to my console, and then type P, and you'll see that the code that we executed between line 74 and 83 results in the vertical bar chart that you see in the lower right hand of the screen. Now you notice that this is not the visual that we saw early on that we're aiming to build, but that's the nice thing about the ggplot2 package, and that is that you can work your way in steps or in layers to get to the ultimate visual that you want. The next thing that we want to do is we want to explicitly tell the end user of our chart what the values of the bars are. And we can do that using the geom underscore text geom. So that geom will allow us to add an additional layer to our chart that contains the labels that were defined in the GGplot2 function. So let's step back a second because I need to point something out that I didn't point out early on when we created the column chart using the geom underscore column geom. And that is that when you notice that we didn't have to set any arguments when we use that particular geom, and that is because it inherits everything from the ggplot2 function that was initiated up here between lines 75 and line 82. And that's the same thing with the geom underscore text geom that we're adding in line 84, because the label that we're using was already defined in our ggplot2 function early on. We don't need to explicitly mention it in that particular geom underscore text function call. So we execute this function. We can see what the result of that is. So let me highlight the code, Control Enter, and then let's print out what it looks like. So now you see that we have those labels added to our visual. And one of the nice things that I like about the GGplot2 library is that it allows you to control a lot of aspects of your visual. In this situation, we're controlling the position of our labels. Later on in the script, we will add annotation to our visual, and we don't want our labels that we have that shows the values of our bars to interfere or overlap with our annotation. And we are making sure that does not happen by taking the labels and pushing them inside the bar using the nudge underscore y argument in a geom underscore text geom. By setting that to negative 0.05, that pushes the labels inside of our bars. The next thing that we're going to do in this visual is control some of the properties of our y axis. And you'll notice that early on I mentioned that the aesthetic function that we use for our mapping maps a column of data from our data frame to an aesthetic. Well, the scale functions that are available to you in the GGplot2 package, they control how that is done. So in line 85 through 88, we are using the scale y continuous function to do that for our y axis. The reason why we're using the continuous version of the scale function for the y axis is because the type of data that is being plotted on our y axis. You'll see if you look at the y axis over to your individual in the lower right hand corner of the screen, you'll see that the data is a continuous number. So that's why we use that version of the scale underscore y function. The properties that we are setting, or the arguments that we are setting, are three arguments. The first one is a limits. We are setting the limit to a value that is fixed, and that value will start at 0 and it will end at 0.75. The reason why we do that, you notice that when you create visuals in many different data visualization software packages, whether it be some that we started off our careers with, which is Microsoft Excel, to Power BI, or any other data visualization tool, you'll notice that the default behavior is normally to change the scale based off of the data that that particular visual is using. So you can have a bar chart in Power BI, and if you can make a different selection often, and what Power BI will attempt to do is rescale that visual based off of the data that has been passed to the visual due to the filters that you apply to it. That can be misleading in data visualization. When you change the scale, the end user may interpret the differences between the different selections that you're making as something that it is not, due to the rescaling. So a best practice would be to make sure that your scale stays the same, so that when you're trying to compare what the situation is based off of the selection that you're making, the scaling is consistent, and you will see a apples to apples comparison versus a comparison that can be misleading. So that is why we're setting our limit of our y-axis to a fixed scale of starting at 0 and ending at 0.75. You'll see that after we do the rescaling. The second thing that we're doing is we are removing the labels from the y-axis, which are these numbers that you see that you can use to gauge what the value of the bars are. Since we have labels in our bars, we do not need that information. So we're removing that, and because we're removing the labels, that means that we don't need a brace as well, so we're moving the braces also. And we're removing both of those by setting those arguments to null. So let's execute that code by highlighting the code. We'll execute it, and then let's look at what the visual looks like after we make that change. So now you see that our visual has been rescaled, where our y-axis is between 0 and 0.75, and we remove the labels that we previously had on our y-axis, as well as the breaks. So what we have up to this point is a vertical column chart or a vertical bar chart. And the visual that we ultimately want is a horizontal bar chart. We can easily switch this over to a horizontal bar chart by using the ch02 function from the GGplot2 package. So let's highlight the code that we have here, execute it, and then display what it looks like after we execute the code. You'll see that what we have is the chart that we initially started with, but with that chart, with the coordinates flipped, to where we went from a vertical bar chart to a horizontal bar chart. Now I've been saying bar, column interchangeably. When I do that, know that they're one of the same to me. I will refer to it sometimes as a column chart and other times as a bar chart. With that being said, I would like to point out a property that you need to be aware of when you use this particular function in GGplot2. Even though our axis has been switched, our y-axis has become our s-axis, and our s-axis has become our y-axis. Even though that has been done visually, underneath the hood, when we refer to our axes, we refer to them in their original state. So when I refer to Zimbabwe, the axis that contains Zimbabwe, Ethiopia, Senegal, what appears to be our y-axis in our visual, when I refer to that in GGplot2 after this flip has been made, know that I still need to refer to that as my s-axis. So this chord flip is only for visual reasons. Underneath the hood, the axis has not been changed. So let's add our annotation. And what I'll do first is execute the code, and then I will explain what's going on. So we now have our annotation added to the code. Now you'll notice here that there's a little overlapping, and that's only because of the way it's rendering in our studio. In Power BI, it's set to not render that way. The annotation will not overlap. But just to make sure that it doesn't happen here, what we can do is we can add a little bit more padding to our expenditure here to make sure that overlapping doesn't occur. So I will execute the code with that added to it so that it will display a little bit better. Okay, so perfect. So let's describe, what happened, how that annotate function that we're using from line 90 to line 95 in our script, how that particular function is enabling us to add an annotation to our visual. So when using the annotate function, the first thing you need to do is tell GGplot2 what type of annotation you're doing. And in this scenario, we're doing a text annotation because we're adding text to our visual. The next thing we need to do is set the label argument with the string that we want to use for our annotation. And if you recall, in a previous video, we went over how we constructed the label _val variable to build out our annotation. And one nice thing I like to point out is that if you recall, if you look at line 60 to 70, we define that variable using the str_wrap function. And one of the nice properties about that particular function is that it allowed us to control the width. And notice that we set the width to 40 so that when the text is displayed on our visual, it won't try to build out that annotation in one string. It will wrap the text when it gets to a width of 40, and send the remaining text to a new line. As you see, uh, that is what's happening. That is what is happening on our visual. The next property or argument that we're setting is our X position of our particular visual. And you see that we set that to max country, which is in this case Zimbabwe. So notice that we're setting our S argument to Zimbabwe even though it appears to be on the y-axis. That is proof that even though we did this core flip on line 89, still underneath the hood, when you want to refer to your axes, you need to refer to them in the original state that it was in when you initially built the visual. Now, because our S-axis is using a data point known as a factor, and remember, we call that a factor is used for categorical data, because it's using data that's of the factor data type. When we're positioning things on our S-axis, we can just give it the name of the value that the name of the data point that we want to map it on that particular axis. So what I mean by that is we want to position it on the S-axis where Zimbabwe is, and we can do that by using Zimbabwe as the value that we want to use for our x-axis. And for our y-axis, we want to position it a little bit outside of our bar. And we can do that by padding the position with a value that is that would make the position further out from what the mass value of our column chart is. And in this case, we can do that by using the max expenditure value that we calculated early on in the script and adding 0.25 to it, and that will position it out further on a y-axis in a position that is outside of our column chart. And again, here it looks like we're doing a x-axis positioning, but we're not. We're actually doing a position annotation right here using the y-axis. Because the core flip function has flipped the axes, it looks like we're doing something that we're not. Next, we define our labels. So right now we have a chart, and it's getting closer to what we ultimately want. But our chart right now doesn't have any labels. We can add labels to our chart. When I say labels, I'm talking about the different type of titles, like the main title, the subtitle, and the caption. We can add those titles to our visual using the labs function. And let's execute the code so you'll see what that looks like. So if I highlight the code from ending at 99 up to 74. If I execute that code, you'll see that we now have titles on our chart. And the titles that we now have are percent of government expenditures on education, which we defined earlier. And then our subtitle, which is the top 7 ranked countries in 2013. And we call that the 2013 portion of this is dynamic based off of the selection we make in Power BI. And one of the nice things I love about GGplot2 that you currently can't do in Power BI without hacking Power BI is we're able to add a caption to our visual that we can use to tell the end users where the source data came from. And we're able to do that using the caption argument in the labs function. So labs is short for labels. Next, we remove the label that we have for our x-axis and also our y-axis, which is down here. And remember, it's down there because of things has been flipped. We don't need those anymore because it's obvious what these values are based on the title we gave our visual. And it's obvious that, what is on our y-axis based off of the labels that we have for each one of our bars. So given that, we can remove country and the total expenditure percent labels from our axes. And we can easily do that by using the slab function and setting the label equal to null. In addition to that, you'll see that we have a legend over here that GGplot is using to give information about the different colors of the particular bars in our horizontal bar chart. We don't need that information, so we also want to remove this from our chart, and we do that by setting our guides function, by using the guides function and setting the fill argument equal to false. So let's execute that code. We're ending at line 102 and starting at line 74. And let's see what it looks like after we execute it. So now you see that we have the chart with those labels removed. The next thing that we're going to do is apply a theme to our chart. And themes are one of the features of GGplot2 that I love. You have some themes that come with the GGplot2 package, but then there are helper GGplot2 packages that you can use to that gives you access to additional themes. And the theme that we're using here is the theme_few. The theme_few theme is based off of principles that were developed by a prominent and well-respected data visualization expert, Stephen Few. So what that theme does is it will take principles that he has developed over the years and apply it to your visual, all in one function call. Now let me show you how it looks after I add the theme_few to the visual. And you see what happened is that it formatted what are known as the non-data elements of the chart and applied principles and formatting rules to it based off of what Stephen Few think are best practices when it comes to data viz. And one of the biggest things that Stephen Few, one of his biggest principles is that he believed that you should be a minimalist when it comes to data visualization, that you should be very stingy with your real estate. If you add something to your visual, it should mean something. So we're almost done. We're almost at the point to where we have the final version of the chart that we want. There are just some additional things that we would like to do, and that is we would like to change the position of our titles, and we would like to change some of the the font size of our caption, and there's a couple other things that we'd like to do. And we can do those, make those changes using the theme function. And you see that's being done from line 104 to line 108. The theme function allows you to modify different components of your chart, and it allows you to do so using the element function. Here, the element function that we're using to modify the components that we want to modify, which are the plot title, the plot subtitle, the plot caption, and the access text that you see highlighted in this code block here. All of those components are modified using the element_text function. So using the element_text function, we are able to modify the position of our title by changing the hjust argument. And using a value of 0.5 will center that text in our visual. So if you use a value of 0, it will left justify your text, which is that's the current value that's being used right now. If you use 0.5, it will center the text, and if you use 1, it will justify your text to the right. So we do that with our plot title, and we also increase we change the size of our text used in the plot title to 20. And for our plot subtitle, we also center that, and we change the size of that to 10. In our caption, the only thing we're doing is we're keeping the same position, but we're changing the size of the text to 8. So let's execute the code. In this situation, since we're at the end of the script, we can execute everything, start ending at line 109 and beginning at line 74. In doing so, you'll see those changes being made to our visual. Notice how we were able to use the GGplot2 package to develop a visual with a lot of detail that will be extremely hard to do using native functionality in Power BI. In the next video, we will wrap things up, and I will provide you with some resources that you can use to help you learn more about how you can use the GGplot2 package to create some amazing visuals using the R programming